Hi guys, welcome back to the channel. In this lecture, we are going to calculate the load factor for this frame structure, in which you can see that the point load is acting on this column AB and one point load is acting on this beam BC. Okay, so this frame is basically the combination of two columns and one beam, right? So we need to calculate what is the value of this lambda. Okay, lambda we need to calculate, which is also known as load factor. Okay, what is load factor? We have already discussed, right? So basically, to find the value of load factor, first basic step in the plastic analysis we need to calculate the static indeterminacy of this frame. Okay, what is the static indeterminacy of this frame? As you can see that at this joint there will be three reactions, one vertical, one horizontal, and one moment will be there, right? At this joint there will be one vertical reaction, one horizontal reaction, and no moment will be there because there is one pin. This is the pin joint. Okay, so the static indeterminacy will be total number of reactions are basically 5, right? And equilibrium equation will be 3. So static indeterminacy of this frame is 2, right? And this static indeterminacy basically is external static indeterminacy because there will be no internal static indeterminacy. Okay, this is an open frame structure, right? So basically the static indeterminacy of this frame is 2. Okay, what are the possible location of hinges? Possible location of plastic hinges. Okay, so what are the possible location of the plastic hinges, where the plastic hinges can form? Okay, this is a natural hinge. Okay, this is the natural hinge. So this is not the plastic hinge, remember that. Okay, at this point plastic hinge cannot form, okay, because this is the point of natural hinge, right? Here the plastic hinge can form at this point under this point load. Okay, at this joint B, under this point load, at this joint, and at this support. Okay, so total possible location are, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, so total so n is equals to 5. That this is number of possible location of plastic hinge. Okay, so this is the case, right? Now number of independent mechanism will be equals to n minus of static indeterminacy, right? So number of independent mechanism will be location of number 5 are the possible location of plastic hinges, and static indeterminacy is 2. So basically we will be having 3 independent mechanism. Okay, 3 independent mechanism. Okay, so what will be those 3 independent mechanism? Okay, so that we will be discussing now, right? Okay, so the first mechanism will be, let us suppose the first mechanism is take place in this beam, right? So if there is a beam mechanism in this frame, beam mechanism BC in this frame, so there will be beam mechanism, and the hinges will form like this. Okay, this is one mechanism. This is mechanism 1 in beam AB. Okay, so this is the first independent mechanism, right? Okay, second independent mechanism will be when there is a beam mechanism in this column. Beam mechanism in column AB. Okay, when there is a beam mechanism in column AB. If there is a beam mechanism in column AB, if let us suppose this is our frame, the plastic hinge will form at this B point, at this B point, and this is the point of natural hinge. So one plastic hinge will form under this point load. So the B mechanism in column will look like this. Okay, when the plastic hinges are forming at this B point, and at this, let us suppose this is E, this is F, and this is F. Okay, at E point, right? So this is also one mechanism which is independent mechanism. This is also a independent mechanism. Okay, there should be no doubt in this, right? To have a beam mechanism in this column, you need to have two hinges. Okay, one is natural hinges. So the one hinge will form at this point and one hinge will form under this point load. Okay, and also remember that the hinge will form, I am showing that hinge is formed at this joint, but it will form in this column. Okay, the hinge will form in the weak member. Remember that the hinge will form in weak member. Okay, so this is one independent mechanism, and this is other independent mechanism. One more independent mechanism is there, which is sway mechanism. So in sway mechanism, what is happening is that this frame will sway. Okay, and the hinges will form at this B point, this C point, and at this D point. This is the natural hinge. Okay, this is not plastic hinge, this is natural hinge. So this frame will sway to the left. Okay, so this is one sway mechanism, or you can say that panel mechanism. Right? So these are basically our three independent mechanism. Okay, these are basically three independent mechanism. Why independent? Because these three mechanisms are independent to each other. Okay, this beam mechanism is not dependent upon this beam mechanism. This beam mechanism is not dependent upon this sway mechanism. Right? So now, first we will be calculating the collapse load for these mechanism, right? And then we will be combining these mechanism to get some combined mechanism. Okay, we will be combining these mechanism to get combined mechanism to get the better value of lambda, right? So now, first we will be calculating the collapse load when there is a beam mechanism in beam BC, right? So now let us take this frame, and mechanism is taking place in this beam, in this BC beam. Okay, one point load is acting at this hinge, at this plastic hinge point, then the value is 60 lambda, right? And there is one point load acting, the value of which is 40 lambda. Okay, so here the mechanism is in BC beam. Okay, so now using the concept of virtual work done method, virtual work principle. So this is, let us suppose, direction of the theta. This is theta, this is theta, and this is theta. These are plastic points of these. At this point, the plastic hinges are forming. Okay, the plastic hinge will form in the weak member. Okay, so generally what happens is that the plastic hinge will form like this. If this is your frame and you are saying that this is MP1, this is MP2, and this is MP1. So if MP1 is greater than MP2, so for beam mechanism of BC, it will look like this. You can see that the plastic hinges are forming in this column. Okay, these are the point of plastic hinges. The plastic hinges are forming in the weak member. Okay, so now if you apply the virtual work principle on this mechanism, I can write external work is equals to internal work. Okay, so I can say at this point the plastic hinges is forming, so internal work will be 240 into theta. Why 240? Because the plastic hinge will form in weak member, and the plastic moment capacity of this column is 240 and this beam is 720. Okay, plus at this point the plastic hinge will form in this CD member, so again 240 into theta, plus what about this point? The plastic moment capacity is forming in the beam, and the moment capacity of this beam is 720 into theta plus 720 into theta. Okay, one moment will be there, one moment will act in this direction, one moment will act in this direction. Here the moment will act in this direction. These are our direction. This is the direction. These are the direction. These are our plastic moments, and I have also shown the direction of these moments, how they are acting. And what about the external work done? External work done will be equals to 60 lambda into this distance is, if this is 10, so 60 lambda into 10 theta. Okay, there should be no doubt in this, right? So theta will cancel out each other. Okay, so final equation will be, final value of lambda will be 240 into 2 plus 720 into 2. This is 920 over 600, and this is equals to lambda divided by 600. So this value comes out to be, lambda comes out to be 3.2. Okay, so collapse load factor when there is a beam mechanism in BC is equals to, lambda is equals to 3.2 corresponding to mechanism 1. And what is mechanism 1? Mechanism 1 is that mechanism when there is a mechanism in this BC. Okay, so lambda comes out to be 3.2. Now what about the value of lambda when there is a mechanism in this column? So when the mechanism is taking place in the column, okay, the plastic hinge will form at this point and at this point where this point load is acting. Okay, so during collapse it will deform like this. So this value is again theta, this value is theta. Okay, here also this is theta and this is theta, right? Only this portion will deflect because plastic hinges is forming on this BC in this column AB. So during the collapse, during the collapse, only this portion will deflect. Okay, this point load is still acting at this point 60 lambda. Okay, so during collapse only this portion will deflect, and the point load acting at the point of this plastic hinge is 40 lambda. Okay, so if you apply the principle of external work done, if you apply this equation, this principle of virtual work done, in which external work done is equals to internal virtual work done. Okay, so I can write what is external work done. External work done, virtual work done is 40 lambda into this distance is 5, so 5 into theta, 5 into theta. This will be equals to mp, or you can say that 240 into theta plus 240 into theta at this E point, right? And plus 240 into theta for this B point. Okay, A, this is B, this is A, this is E. So this is for E point and this is for B point. At A, there is a natural hinge, so there will be no plastic moment. Okay, so if you the theta will cancel out each other. These terms will cancel out each other. So the equation will be 200 lambda equals to, this is what? This is 720. So lambda equals to 720 divided by 200. So this value will be 3.6. Okay. So lambda is equals to 3.6 when there is a mechanism in column A, B, and let us suppose this is mechanism 2. Okay, this is an independent mechanism, right? Now let us discuss about the sway mechanism, which is another independent mechanism. Okay, so in sway mechanism, the frame will sway to the left. The plastic hinge will form this point. Okay, and this is the natural hinge. So it is different from plastic hinge. Okay, don't get confused. There won't be any movement over here. This is natural hinge. Okay, so one load is acting 60 lambda, another load is acting 40 lambda. Okay, and remember that in panel mechanism or sway mechanism, the plastic hinge will always form at the end of the columns. Okay, there will be no plastic hinge at the between the columns. Okay, or in the beams. Only the plastic hinge will form at the top and the bottom of the column. Remember that. Okay, so in this sway mechanism, the plastic hinge is forming at the top of the columns and at this bottom of the column, right? So now, and this is, let us suppose, our original axis. So here this is theta, here this is theta, right? Here this is theta and here this is theta. Okay, so plastic moment will act like this. Here it will act like this. Here again it will act like this, and here again it will act like this. So this is the direction of the rotation. So plastic hinge will opposite to this rotation. Okay. So now if you apply the concept of virtual work, so I can write external virtual work is equals to internal virtual work. What is the value of external virtual work? External virtual work will be due to external load. Okay, so it will be 40 lambda into, what is this distance from this original axis to this axis? This will be 5 into theta, 5 into theta. So this is the external virtual work done. Okay, there will be no work done due to this load because there is no deflection under this point load. Okay, now what about the internal virtual work done? Internal at this point, oh sorry, this is the point of natural hinge, so there won't be any moment. Okay, no moment, no plastic moment. Okay, so at this point the internal virtual work done will be mp into theta, or you can write 240 into theta. Okay, at this point the moment will be again 240 into theta, because the hinge will form in the weak member. Okay, plus again at this point it will be again 240 into theta. So again this value will be 200 lambda theta. This is equals to 720 into theta. Theta will cancel out each other. Again lambda comes out to be 3.6. Okay, so lambda will be 3.6 for sway mechanism. Okay, so how to calculate the collapse load factor in the independent mechanism? It is very easy. Okay, basically it is very easy to calculate the collapse load factor for the independent mechanism. But when you combine these mechanisms, then the problem will become little bit tricky. Okay, so how to solve those things we'll discuss now. So here again lambda is equals to 3.6 for mechanism 3, which is sway mechanism, right? Now let us combine mechanism 1 and 3. Okay, first I'm combining the mechanism 1 and mechanism 3. Okay, when you combine mechanism 1 and mechanism 3, right, see it very carefully. Okay, this is very important concept over here which I am about to discuss. Okay, so let us suppose if this is frame, this is the initial condition of the frame, and there is a mechanism forming in this and there is a beam mechanism in this frame. Okay, beam mechanism in AB. Okay, plus I am combining two mechanism 1 and mechanism 2. This is natural hinge. Okay, this is again A, B, C, D. Here this is the direction of rotation is theta. Here again the direction of rotation is theta. Here again this is the direction of rotation theta. Okay. Now here you can see that this is the direction of rotation theta, which is what you can say, which is clockwise. Okay, here also you can see that this direction of the direction of the rotation is theta. Okay, the basic purpose of combining the mechanism is to the cancellation of hinges. Okay, so basic purpose to combine mechanism is to cancel the formation of hinges, is to cancel the formation of plastic hinges. Okay, what I meant by that is that if you are combining the mechanism in this way, and by combining those mechanism, if plastic hinges is not forming at a point which it's supposed to happen, suppose if you are combining these two mechanism, okay, and after combining these two mechanism, you came to know that the plastic hinges is not forming on this B point. Okay, when the plastic hinges is not forming, or there is a cancellation of plastic hinge, then what you are doing, that you are minimizing the internal work. Okay, and when you are minimizing the internal work, by minimizing the internal work, you will get the less value of load factor. You will get the less value of load factor. Okay, if after combining these two mechanisms, okay, somehow what you can say that there will external work done will be there. Okay, but if you somehow cancel the formation of plastic hinge, then you are minimizing the internal work. Okay, because internal work is depend upon the plastic moment capacity. Okay, if at this point the hinges is not formed, then this point cannot behave like a plastic hinge. Okay, So the purpose of this combining the mechanism is to cancel the formation of plastic hinge. Okay, this thing we will see in this example. Okay, now let us see that this member is rotating in which direction? In clockwise direction. Okay, this member is rotating in clockwise direction. Similarly, this member is also rotating in clockwise direction. Okay, and if you combine these two things, this member will look like this. Okay, and again this angle will be theta. So initial angle between these two members is 90 degree, and after you combine these two mechanisms, still the angle is 90 degree. So there will be no plastic hinge at this B point, right? No plastic hinge at this B point. No plastic hinge at this B point. Okay. If you are giving the theta rotation at at this B point in clockwise direction, and again theta rotation in clockwise direction for this beam, then both will add, and the angle between these two members will be constant. Remember that. Okay, not remember that, you can try to understand. Okay, this member is coming down by theta, this vertical member is moving in clockwise direction, again with the value theta. So initial angle was 90 degree between these two members, still the angle is 90 degree. So if plastic hinge is there, let us suppose if plastic hinge is formed there at B, then the angle should not be equal to 90 degree. Okay, here the angle between the members is 90 degree, so the plastic hinge will not form at this B point. So the basic important concept we learn from here is that no plastic hinge will form at B point. In the last lecture we discussed this thing with the concept of net moment. Okay, at this B point there is the moment will be less. The moment is less, that's why the plastic hinge is not forming at the B point. That thing is also correct, but this is a better way to understand, because this concept we will be using in solving some tough problems. Okay, and or you can say there are some little bit tricky problems, right? Because every time we cannot say where the moment will be maximum or where the moment will be minimum. We can't predict. Okay, so this concept will be using in further problems, right? So no plastic hinge will form at B. This point should be clear. Okay. Now, what about C? This is the point of natural hinge. We all know that. What about this F, and this is C? And let us discuss about this C point. Okay, C point. So at C point, you can see that this rotation is in which direction? Anti-clockwise. This rotation is in clockwise direction. Okay, so initially what is happening is that if you combine these two things, initially the angle between these two members is 90 degree, right? So when the plastic for this beam mechanism, this member is rotated by theta. Okay, and again this member is rotated by theta, right? Now, if someone asks what is the value, what is the angle between the two members now, what will you say? Okay, so the angle between the two members will not be equal to theta, right? So it will be somewhere between 90 minus of 2 theta. And what is the change in angle? Change in angle will be 90 minus of 2 theta. So this will be equals to 2 theta. Okay, this is the change. So plastic hinge will be there. Plastic hinge will be there. So at C, plastic hinge, no cancellation of plastic hinge. At C, no cancellation of plastic hinge. Why? We have already discussed. Okay, right? There should be relative rotation between two members for if the plastic hinge is there. Okay. Now let us come to this D point. D point. At this D point, initially there is no, in the beam mechanism, in case of beam mechanism, there is no plastic hinge, right? When you are combining it with sway mechanism, the plastic hinge will form at this D point. Okay, the member will rotate in this. Initially this member is straight, so now in sway mechanism this member is rotating in clockwise direction, so net rotation will be in clockwise direction, right? So plastic hinge will be there at point D, will form at point D. Okay, so D is also the point of plastic hinge. Now let us talk about, what about F? F, in sway mechanism there is no plastic hinge, so plastic hinge will always be there, okay, in combined mechanism. So by combining the mechanism, we are able to cancel the plastic hinge at this B point. So at this point, internal work, the capacity of the structure the internal work is reduced basically. So when the internal work is reduced, the load factor will also be reduced. Okay, we somehow reducing the internal work basically, right? Internal virtual work by cancelling the hinges, by cancelling the formation of hinges, right? So now we understood that the plastic hinges are forming at this point, this and this D point, right? In combined mechanism, when you are combining the mechanism 1 and mechanism 3. Okay, so if you combine mechanism 1 and mechanism 3, it will look like this. Okay, this is natural hinge, this is plastic hinge. At this point also there is formation of plastic hinge. This point or F also there will be formation of plastic hinge, and this point will be, the angle between these two members will be 90. There is no plastic hinge. There is no plastic hinge at this B point. Okay, this is A, this is B, this is F, this is C, and this is D. So one load is acting, this is 60 lambda, and here the load is acting 40 lambda. This angle is theta. Okay, this angle is again theta. This will be theta, this theta, and this will be theta. This will be again equals to theta, right? These two lines are parallel, so this is alternate angles. Okay, this theta will be equals to this theta. This is 90 minus theta, so this will be theta. Okay, so by symmetry this theta will be equals to this theta. Okay, because this deflection will be same for both the cases, right? For both, for this portion I can write 5 theta 1 equals to this theta 1, this theta will be equals to this theta, right? That you can calculate it is very easy. Okay, so this is the case. So if you apply the principle of virtual work, if you apply in this combined mechanism, so what is external virtual work? External virtual work. External virtual work is basically 40 lambda into 5 theta plus. This is this is the initial position, and it is deflected to this position. So this distance is 5 theta. Okay, this vertical distance is 5, right? And here also it will be 60 lambda into 10 theta. So this is external virtual work, and this should be equal to internal virtual work. Internal virtual work. And what is internal virtual work? Internal virtual work will be, at this point there is no plastic movement will be there at this point, because this is the point of natural hinge, right? This is natural hinge. Okay, at this point there is no plastic hinge, so no work done. At this point this is the direction of MP. At this point this is the direction of MP. Similarly, if this is the direction of rotation, the direction of the MP will look like this. If this is the direction of rotation, direction of MP will look like this. Okay, so I can write 720 for this point F. I can write internal work done is 720 into theta plus 720 into theta. Okay, for this point C, again I have to write 240 into theta plus 240 into theta, because the hinge will form in the weak member. And for this point I need to write plus 240 into theta. Okay, theta is my virtual displacement, right? So this value will become, so this value will be 720 into 7 into 2 plus 240 into 3. So this is 2160 into theta, and this will be equals to, this is 200 lambda theta plus this is 600 lambda theta. So theta will cancel out each other, right? So lambda will be equals to 2.7. Okay, so you can see that here, you can see that by cancelling the formation of hinge at B point, the load factor is reduced to 2.7. okay, when you combine mechanism 1 and mechanism 2, mechanism 3, right? So you can see the advantage of cancelling the hinges. Okay, now what happened? Now what happened when you combine mechanism 2 and mechanism 3? Okay, combining mechanism 2 and 3. So when you are combining mechanism and 2 and 3, which means that you are combining the beam mechanism in this column AB and panel mechanism or sway mechanism in the frame. Okay, so this is, let us draw the beam mechanism in the column AB. Okay, so this is the beam mechanism will look like in column AB. Okay, and this is the sway mechanism will look like in this whole complete frame. This is the point of, again, natural hinge. Okay, this plastic hinge will at sway is forming at these points, and the beam mechanism, the plastic hinges are forming at these 2 points. Okay, this is again natural hinge. Okay, and again we are combining these two mechanisms, right? Why we are combining the mechanism? To cancel the formation of hinges, to get better to critical value of lambda. Okay, so now see it very carefully. Again, we need to calculate, we need to find the points where we can cancel the formation of hinges. Okay, so at this point the rotation is theta in clockwise direction. Here also the direction is in theta is in clockwise direction. Clockwise. Both the direction of the rotation is clockwise, right? Now here you can see that this rotation is in anti-clockwise direction. Anti-clockwise direction. Okay, so now what is our condition? When you are combining these 2 points, just look at these 2 points, B in sway mechanism, B in beam mechanism. Okay, so when you are seeing, due to in the sway mechanism, this initially the member between the angle between at this B, the angle between these 2 points is 90 degree, right? So when there is sway mechanism, this angle is changed by this theta rotation. Okay, this is theta. Okay, now if in this mechanism initially the angle between the member is 90 degree, now it is changed by theta. Okay, this angle, this is theta. So if you combine these two things, this in sway mechanism, this is moving to the clockwise direction, and in the beam mechanism, this is moving in anti-clockwise direction. So at this point, there should be no rotation. Net effect of these two will cancel out each other. will cancel out each other. So at this point, the angle will remain equals to 90 degree. Okay, you need to visualize this thing. Okay, you need to visualize this thing. Initially you are rotating this member in clockwise direction, and again you are rotating this member in anti-clockwise direction. So net rotation will be zero. Net rotation will be zero. The angle between these two members will be 90 degree, right? It will remain 90 degree. If you combine the mechanism and you see the what you can discuss about this point B, if you see this point B, when you are combining the mechanism 2 and 3, the angle between the members will remain same. So there will be no hinge formation. There will be no hinge formation at B point. Okay. So it's better to discuss in this way rather than that net moment at B is less. Okay. It's better to visualize the things in terms of rotation. Okay. Right. So this is the case. Now let us come to this point, this E point. What is happening at E point? Whether the plastic hinge will form at E point or not. Okay. And this is at this way, this in sway mechanism, this is E point, right? So I'm coming to the E point. So in sway, this is the rotation is clockwise. Okay, the rotation is clockwise, right? If I am considering about the sway, the rotation is clockwise, no doubt in this. Okay, and if you see this E point in the beam mechanism, it is looking like this. Here the rotation is clockwise. Okay, I'm talking about this member below this plastic hinge point. Okay, below this plastic hinge. Okay, so now you can see that this is the rotation in this beam mechanism theta, and again this is the rotation in this column theta. Okay, at this point these both rotation will act, these both rotation will add. Okay, these both rotation will add. Okay, these rotation is not what you can say that they are not cancelling each other. Okay, it's how to visualize this thing. Initially this member is okay, this you can see like this. If there is no plastic hinge at this point, this portion will remain straight, this portion will remain straight. Now due to formation of plastic hinge, this is rotating in clockwise direction. Okay, and again you can see here, if there is no plastic hinge, this member will remain straight. Okay, this is not the plastic hinge point, but you can see the rotation at this point, at this E point, the rotation is clockwise. Okay, so at this E point, both the rotation will add to each other. Okay, so net rotation will be 2 theta. Okay, the rotation is not cancelling each other. Okay, these are adding, they both are adding to each other. So that's why the what you can say that these two, initially these two members are straight. Okay, what is happening is that if this is the rotation in the beam due to beam mechanism. Okay, due to this is E point, due to and in the sway the rotation is, the rotation is theta at this E point. This is also in clockwise direction. Now if you combine both the things, the net rotation will increase. The net rotation will be 2 theta at this point. Okay. So net rotation will be 2 theta. So plastic hinge will form at this E point. There is no cancellation of plastic hinge at this E point, right? So, and what about this C point? C point, in this there is no plastic hinge, but at the C point there is a plastic hinge. So net rotation will be theta. Net rotation is theta. Here the angle is 90 degree and here the angle is changed to 90 minus of theta. Angle between this angle is 90 minus theta. So net angle change is theta basically. So plastic hinge will be there. Plastic hinge will be there in combined mechanism. Okay, C. And D also, the plastic hinge will be there because there will be rotation of theta. Okay. From the initial axis, right? So now we came to know that the plastic hinges are forming at E, C and D point. This is a very important thing to understand. Okay, you need to visualize little things, okay, where there is a possibility of hinge cancellation by visualizing the rotation, how the members are rotating. Okay, so now the plastic hinges are forming at E, C and D point. Okay, and at B there is no plastic hinge. At B, no plastic hinge. No plastic hinge, right? So our case will look like this. Or you can say that better to draw the deflected shape. So these are our points of plastic hinges. Okay, and this is our initial position of the frame. Okay, this distance x, let us suppose, will be equal to this distance. Why? Because we are neglecting the extensibility of member. Members are considered inextensible. Okay, so there should be no axial deformation along the member. So this x should be equal to this x. Okay, and net rotation at this point will be 2 theta. Net rotation at this point will be 2 theta. Okay. Right? So now if you apply the principle of virtual work done over here, if you apply the principle of why this is theta, because 1 theta is adding from this beam and 1 theta we are getting from sway. So if both will combine, there is a net rotation of 2 theta available at this point. Okay, now if you apply the the principle of virtual work done, I can write this is the point of this is natural hinge. Okay, it will not provide any moment over here. This is hinge, right? So the direction of the moment will be like this, MP. Okay, here the direction of this is rotating like this, the direction of moment will be like this. Here the direction of moment will look like this. Okay, so what is the external virtual work done? External virtual work done will be 40 lambda into 5 into 2 theta. Okay, is equals to internal work done. What is the internal work done? 240 into 2 theta at this point, 240 into theta at this point C, plus 240 into theta at D point, this point, right? So if you solve this thing, 40 into 5 into 2, this is 400 lambda theta, and this is equals to, this is 240 into 4. So 240 into 4 will be 960. 960 theta. Theta will cancel out each other. So lambda will be 960 divided by 400. So this value is, I think this value will be 96 divided by 40 is equals to 2.4. 2.4. So lambda is equals to, again, 2.4 when you combine the mechanism 2 and 3, right? So if you are combining the mechanism 2 and 3, you are getting the value of lambda 2.4. Okay, so this is again the most critical out of these 5 mechanisms which we have discussed till now. Okay, now let us discuss one more combination. Okay, so now what happens when you combine mechanism 1 and mechanism 2? If you combine mechanism 1 and mechanism 2, so if you combine mechanism 1 and mechanism 2, what will happen? Okay, let us first see what is mechanism 1, how the rotation of member taking place in mechanism 1. Okay, this is mechanism 1. Here the direction of rotation is, this is anti-clockwise, here also this is anti-clockwise, right? And if you combine it with beam mechanism in column, so it will look like this. Here the rotation will be is theta anti-clockwise, and again here this rotation is theta anti-clockwise, right? So now let us see. Initially the angle between these member is 90 degree. So if you consider this beam mechanism, first beam mechanism for mechanism 1, the angle changes to theta, right? And again, if you consider the beam mechanism, initially the angle between the member is 90 degree, and now due to rotation this angle changes to theta. So if you combine these two things, it will if this is the initial position of the member, the angle between them is 90 degree at B point. So now the situation will look, situation is looking like this. So angle between these 90 degree is changed. Okay, and how much it is changed? It is changed by 2 theta, right? So at this B point we will be having hinge. Okay, so at B point hinge will be there. B point hinge will be there. Okay, similarly hinge will form at C point. Okay, and the rotation will be theta at this point. Hinge will be there at C point, and hinge will also be there at this E point. Okay, so if you combine these two mechanisms, it will look like this. Okay, so these are our points of plastic hinges. Right? And you can see that you are not, this is natural hinge, and you can see that in these two mechanisms you are not able to cancel the formation of hinge. Okay, so its load factor will be more. Okay, so how to calculate the load factor for this? Again, use the concept of principal virtual work. So if you combine the principle of virtual work, I can write, this is theta, this is theta. So here also this is theta, this is theta, this is theta, theta. Okay. So I can write, if you apply the concept of virtual work, I can write What is external work done? External work done will be 40 lambda into 5 theta plus 60 lambda into 10 theta, which this is equals to, what is the internal work done? Internal work done at this point will be, at this point, first let us talk about this E point. At this E point it will be 240 into theta plus 240 into theta. Then let us come to this B point. At this B point, again the work done will be 240 into theta plus 240 into theta. At this F point it will be 720 into theta plus 720 into theta plus, and again let us come to this point, so it will be again 240 into theta, right? So this is our internal work done. So if you solve this thing, so this is 800 lambda theta total external work done. So this will be 240, 1, 2, 3, 4, 5. 240 into 5 plus 720 into 2. This will be 2640 divided by 800. So lambda comes out to be 3.3. Okay. So there is no need to combine these two beam mechanisms. Okay. So lambda is coming out to be 3.3. You are not able to cancel any hinges over here in this mechanism. So that's why the lambda is coming more. Okay. Now let us combine all three mechanisms. Let us combine all three mechanisms. So now lambda is 3.3 when you combined mechanism 1 and mechanism 2. Okay. Now what happened when you combine mechanism 1, 2 and 3? What happened when you combine mechanism 1, mechanism 2 and mechanism 3? Okay. This thing we will be seeing now. Okay. So okay. So here this is this situation. This is our beam mechanism plus this is beam mechanism column. This is sway mechanism. Okay. So in this beam mechanism, the plastic hinges are forming at this point. In this beam mechanism of column, the plastic hinges are forming at this point, and this sway mechanism, the plastic hinges are forming at these 3 points. Okay, this is the point of natural hinge. This is again natural hinge. This is again natural hinge, right? And these all rotation at these points are theta. This is theta. This is theta. This is theta. This is theta, right? Similarly, this is theta, this is theta, this is theta, and here also this is theta, this is theta. So now the plastic hinge will form first. The plastic hinge will form at this E point, which we are showed, where the plastic hinge form at this E point. The plastic hinge will form, definitely plastic hinge will form at this E point, and this D point also the plastic hinge will form. Okay, we need to decide about this C point and this B point. Okay, so let us talk about first B point. Okay, so at this B point, at this, what happened at this B point? If you see this thing, if you combine these two things, the net rotation, if you combine these two things, is what you can say that is 0. If you combine these two mechanisms, the angle will be remain 90 degree between these two members. And again, so if you combine these two things, at joint B, the situation will look like this. Okay, but again, if you combine with this mechanism, the situation will, initially the situation was looking like this, so the situation will change to this. So angle between the member is changed from 90 degrees. So plastic hinge will form at B point. So plastic hinge will form at B point. Okay. And what about C point? At C point, what is the situation? This is not affecting the at this point, in this mechanism there is no rotation at this C point. Okay, so we will be focusing on these two mechanisms. Okay, if you look at these two mechanisms in C, we have already discussed that if you combine this mechanism with this mechanism, the plastic hinge will form at C. Okay, so at C, plastic hinge will be there. Plastic hinge will be there because initially the angle between these two members is 90 in sway mechanism, so it changes by theta. Similarly, in this portion, in this beam mechanism, the angle changes to theta. So our situation will look like this. So there is a net rotation of 2 theta. Okay, net rotation of 2 theta. So the angle changes by 2 theta. Okay, so angle between these two members is now 90 minus 2 theta. If you combine these three mechanisms, so plastic hinge will definitely form at C, right? And the plastic hinge will be always be forming at this D point, this F point, right? And similarly at here also. So now the plastic hinge is forming at all points. Okay, we are not able to cancel any single point. We are not able to do any cancellation of hinges, right? So again, the load factor will be more in this case. So again, if initially this is our frame, so plastic hinges are forming at this E point, this B point, this C point, and this D point, and this F point is also there will be one plastic hinge. Okay, so this is natural hinge. So this angle is theta. Here this angle will be 2 theta. Sorry. This will go straight and this will bend like this. Okay, our deflection during the collapse will look like this. This is theta, this is theta, this is again theta. Okay, this is theta, right? So at this point the 40 lambda load is acting. Similarly at this point the 60 lambda load is acting. Okay, this distance will be equals to this distance, member extensibility, right? So if you calculate again use the principle of virtual work done. So you can write 40 lambda into 5 theta, sorry, 40 lambda into 5 into 2 theta. Okay, 40 lambda into 5 into 2 theta. This angle is 2 theta. Okay, these two rotation will add. These two rotation will be add, and there will be rotation of 2 theta. 40 lambda plus 5 2 theta plus, at this point there will be only 1 MP. So MP is 240 into theta plus, at this point again there will be 240 into theta plus 240 into theta. Here also there will be one internal work done, 240 into theta, and at this point it will be 720 into theta plus 720 into theta. This is internal work done, and this at this point the external work done will be 60 lambda into 10 theta. Okay, this is 10 theta, right? So this is also the point of plastic hinge basically. Okay, so if you calculate this thing, this will be again equals to 240 here. Okay, at this point this angle is 2 theta, so this will be 240 into 2 theta, right? 240 into 2 theta plus 240 into theta here, 240 into theta here, 240 theta here, and 240 into theta. How many? 2 1 2 3 4, one more, plus 240 into theta. So at this point 240 into theta, D point. At C point we will be having this expression, and at this B point I will be having this expression, and at this E point it is 240 into 2 theta. Okay, and at this point it will be 720 into theta plus 720 into theta. So 240 into 2 plus 240 plus 240 into 2 into 240 into 4 plus 720 into 2. So this is 2880, and this value is, this expression is 40 into 5 into 2 plus 60 into 10. So this is 1000 lambda theta. Theta will cancel out each other, so lambda will be 2.88. Okay, so lambda will be coming out to be 2.88 when you combined all three mechanisms. Okay, 1, 2 and 3. Okay guys, so let us check it once again. 240 into 2 theta here, 240 into theta at this point, 240 into theta at this point, 240 into theta, these 2 points, 720, 240 theta. Okay, so here this is 40 lambda into 5 theta. So lambda coming out to be 2.88. So you can see that the critical one was 2.4. Okay, the critical, the what you can say that the designing load factor will be lambda equals to 2.4, and which happened when we combined mechanism 2 and 3. Okay, so guys, I have discussed this problem in detail. If you have any doubt regarding this problem, you can write in the comment section. Okay, basically in this problem you need to visualize the rotation, how the members are rotating, and how the angles between the members are changing. Okay, that is the important thing. Okay, so guys, we'll meet in the next lecture.